Hey guys, we are going to graph a polynomial today, okay? We are so excited. So whenever we're asked to graph something, we always have the option of picking a number for x, plugging it in, getting a y, and graphing the ordered pair, right? But that can be time consuming, or we're not sure what numbers to plug in to give us a good idea of what the graph looks like, right? So there is an easier way, okay? So we are going to follow some steps. So first, we're going to factor and find our zeros. Second, we're going to look at end behavior. Third, we're going to look at multiplicities. And then there's a fourth optional step that we'll talk about once we get there, okay? So first, I'm going to factor and find my zeros. So this definitely does need to be factored, right? So I'm going to factor this pretty quickly. If you need a review, I will link a video in the corner, okay? So I notice out of these two, I can pull out an x squared, right? Then I'm left with x plus 1. Out of these, I can pull out a -9, and I'm left with x plus 1. Those match, so I can pull those out. So I'm going to have x squared minus 9 times x plus 1. And then this can be factored further. It's a difference of two squares. Again, if you need a review on that, I'll link, excuse me, a video in the corner. But this is going to be, the x squared minus 9 is going to be x plus 3 times x minus 3. And then we still have the x plus 1, okay? So this is this all the way factored, right? Okay, so we factored. Now we're finding our zeros. When I say we're finding the zeros, we're finding where my graph crosses the x-axis, okay? Now to find that, I would plug in 0 for y, right? So 0 equals this. And then what you end up doing is just setting each of these parentheses equal to 0, okay? So that's what I'm going to do. We're going to have x plus 3 equals 0. X minus 3 equals 0, and x plus 1 equals 0. Okay, these are my zeros. I just said 0 like 4 times. Okay, so if I solve for these, I'm going to subtract 3 from both sides. I end up with x equals -3. This one I would add 3 to both sides, right, and get x equals 3. And this one I would subtract 1 from both sides and get x equals -1. Okay, those are my zeros. So what I'm going to do next is plot those on here, right? So I know my graph crosses at -3, at -1, and at 3, okay? But then it's like, great, that helps me a little bit, but what else does my graph do, right? So the next thing, my second step is end behavior, okay? I'm going to show you some words, okay? If you're the person who likes to read things, go ahead and take a screenshot of this to help you know how to find what the end behavior is. If you're like, I don't want to read that, just show me how to do it. That's what we're going to do now, okay? So when we're doing end behavior, we start with the right side of my graph. So we want to know, is my graph going to go up from this point or down from this point, okay? And to figure that out, we look at our leading coefficient, okay? So it doesn't really look like there's a leading coefficient, right? But there's really like an invisible one there, you could say. Pretend like my pencil was ready. But all we really care about is if it's positive or negative out there, okay? If it's positive, my graph's going to end up. If it's negative, my graph's going to end down. So since we're positive out here, I'm just going to do it in pencil, knowing that this side of my graph goes up, okay? Then to figure out what the left side of my graph does, if from this point we go up or down, I look at the degree, okay? The highest exponent when it's all multiplied together. So from here, the highest exponent is 3, right? And all I care about is if it's even or odd, okay? If it's even, my left side is going to do the same thing as my right side. If it's odd, like this one is, my left side is going to do the opposite of the right side, okay? So in this case, it's going to be opposite, so the left side is going to end down, okay? All right, we've done steps 1 and 2. Step 3 is to look at multiplicities, okay? That is if there's more than one parenthesis that is the same, okay? So in this case, all of my zeros have a multiplicity of 1, okay? If I were to have, again, I'm going to use pencil again because this is just a what if. If I were to have had another x plus 1 here, then this 0, the -1, would have a multiplicity of 2. Okay, pretend I had two 2 more of those. So I had 3 of the x plus 1s. Then this 0 would have a multiplicity of 3. Okay? But in this case, all of them have a multiplicity of 1, which means my graph is just going to go straight through these points. Okay? If you have an odd multiplicity, 1, 3, 5, it goes straight through. Okay? It might have a slightly different curve, but your teacher probably isn't too worried about that right now, just that you know it goes through. If it has an even multiplicity, 2, 4, 6, 8, then it bounces off that spot. Okay, kind of like a parabola. If you want to see an example like that, I will link a video in the corner. Okay, but all of these guys go straight through. Again, this side ends down. We go straight through all of those points. Okay, and that is my graph. Okay. The last thing is my optional 4th step, okay? My 4th step would be to plug in some other points to know exactly how high and low these bumps are, right? I could plug in a -2 and see what I got for y, but a lot of teachers probably aren't too concerned about that at this point. You might later on. That's why I didn't actually put tick marks on the y-axis, because I'm not too concerned right now about how high and low those bumps are. But if you want to know, or if your teacher wants you to know, for that optional 4th step, plug in some more points like -2, 0, 1, and 2 to figure out those other points along there. Okay. All right. But hopefully this made sense. If you need some more examples, I'll link a playlist. Thanks.